Okay, so these are the notes on section 1.3. And it starts out with the definition of a linear function, that f at x equals mx plus b. And this is a form of a linear function. Notice that the highest exponent on x is a 1, and m and b are real numbers. They're just constants, m and b. So a function of the form f at x equals x squared plus 1, that would not be linear because of the fact the exponent on x is a 2. Something like f at x equals 1 over x is also not a linear function because the x is in the denominator. Something like f at x equals the square root of x, that also is not linear because there's a square root around the x. However, something like f at x equals 2x minus 3, that is a linear function. It matches our form mx plus b. You may recall from your previous algebra course that m is called the slope of a line. And by definition, the slope of a line is the change in y's over the change in x. Or you may know it as y2 minus y1 over x2 minus x1. You simply just subtract the y's, and in the same order you subtract the x's. The slope of a line is also called the average rate of change. In order to find the slope of a line, you need 2 points. And we call these points x1, y1, and x2 and y2. And that's what I've done right here. I subtract the y's, and in the same order I subtract the x's. Okay, so we see this often in real life all the time. When we're perhaps entering a building on a handicap ramp, and maybe the ramp is measured to be 12 feet horizontally with a 1 foot rise. So we would say that the slope of that ramp, or the grade of that ramp, is 1 over 12, and as a percentage it would be 8.3% grade. So we do see slope in the real world, as here in this example, as the grade of a handicap ramp. And also we talk about the grade of some hills that some trucks should not go up because perhaps they are too steep. Okay, so let's do some examples pertaining to finding the slope of a line. If you look in section 1.3, number 6, for example. Okay, number 6. Given these 2 points, -3, 1, and 3, -5, we're to find the slope of a line passing through these 2 points. So the slope is m equals the change in y's over the change in x's. So I'm going to subtract the y's, that is 1 minus a -5 over -3 minus 3. Subtracting the x's in the same order. So I'd get 6 on top, because this would become a +5, and a -6 in the bottom, which would be a -1. I also could have gone -5 minus 1. Then if I start here from my y, I have to start here from my x. So then I'd have to go 3 minus a -3. Another example, number 10 from section 1.3. Suppose the points are -3, -4, and 5, 1. And the slope of the line passing through those points, m equals the change in y's over the change in x, which is, I'll go here this time, 1 minus a -4 over 5 minus a -3. And that becomes simply 5 over 8 is my slope. You also may see 2 points represented in this notation, number 26. F of -4 equals 5, and I believe that's -5, and f at 4 equals 1. Well, this is function notation. And this means that when x is negative 4, y is 5. This means when x is 4, y is 1. So now we have this notation, function notation, as ordered pairs. So then now the slope of the line passing through these points, m equals the change in y over the change in x, which is 5 minus 1 over negative 4 minus 4, which is 4 over negative 8, which is negative 1/2. Okay. Next, I believe also in this section, number 34, we're asked to do a variety of things. And the first thing we're asked to do is to find the slope of a line. Now, number 34. We are asked to identify the slope and the y-intercept. So if f at x equals 4x minus 1/4, we'll recall our linear function form, mx plus b. It has to be solved for y in order to identify the slope. So the slope of this line is 4. It's the coefficient of the x term. It's the number in front of the x term. The constant that stands alone, you may recall, is your y-intercept, which is called b. And as an ordered pair, that point is 0, negative 1/4. And also, you may recall that the y-intercept is the point where the line or the graph passes through the y-axis. So to be on the y-axis, remember, x has to be 0. Number 54, there we have the equation y equals, this is number 54, y equals 2 plus 3/7 x. Well, once again, it's solved for y. So you can very easily identify the slope and the y-intercept. The slope is the coefficient of the x term, so the slope is 3/7, and your y-intercept is 2, or as an ordered pair, 0, 2. Now, if you look in number 60, the equation is not solved for y. So in number 60, we have 5x minus 2y plus 9 equals 0. So how do we solve this for y? You can circle the y term if you want, and you need to get that by itself. So I will take over the 9, and it will become negative 9. Take over the 5x, it will become negative 5x. I'll divide every term by negative 2 to undo the multiplication, and y will be equal to negative 9 over negative 2 is 9/2, and negative 5 over negative 2 is 5/2. So the slope of the line is 5/2, and the y-intercept is 9/2. And just one more on that, number 56. I'll just backtrack and do number 56 as another example because it's pretty common. 56 is 2x minus 3y equals 12. So again, we cannot recognize the slope and the y-intercept from the form that it's in. So we need to solve for y. So keeping the y there and taking over the 2x, it becomes negative. Divide by negative 3, and y would be equal to 12 over negative 3 is negative 4. Negative over negative is a positive 2/3 x. So my slope is 2/3, and my y-intercept is 4, which again is the point 0, 4. And last in this chapter, or in this section that is, sorry, they're asking us to graph a line. So number 64, it is the line given by y equals 3/2 x plus 1. One of the most efficient ways to graph a line is by the slope-intercept method. And that, of course, is to solve for y. So we can immediately identify the slope and the y-intercept. So first, always solve for y, if it isn't already solved for y. Now, how do we graph this line using this method? Make an x and y axis. And because we know that a point on this line is the y-intercept, then we graph this first on the y-axis, up 1. We know that the slope is 3/2, and the slope is, recall, the change in y's over the change in x's. So this will mean that I'll go up 3 units because it's a positive 3, 1, 2, 3, and to the right 2 units because it's a positive 2. Another way I can get a slope of 3/2 is to go down 1, 2, 3, and to the left 2, because down 3, which would be a negative 3, and the left 2, which would be a negative 2, is still a positive 3/2 because a negative over a negative is a positive. And now I got 3 points I can connect to form my line. And notice that since the slope is a positive slope, the line should be rising from left to right. That as I move from the left to the right, the line should be going up in this direction. Okay, and one more. Again, graphing a line using slope-intercept is number 68. And the line is given by 2x plus 3y equals 15. So it's not solved for y, so I need to solve for y. So I get 15 minus 2x. I'll divide by 3 to get the y by itself, and y is equal to 5 minus 2/3 x. So my slope is negative 2/3, and my y-intercept is 5. So how do we graph this line with this information? Make an x and y axis. And I graph the y-intercept first, because I know this is a point it's passing through. So it's going to be up 5. 1, 2, 3, 4, 5. And then I'll move according to my slope. Always up or down first, then right or left. So because my slope is negative 2/3, I'll come down first, 1, 2. And because it's a positive 3, I'll go to the right, 1, 2, 3. Or I could go up 1, 2, and to the left 1, 2, 3. Always the opposite direction. So then I'll connect, and there's my line. And notice that this time we're falling from left to right. That as I move from the left to the right, my line is falling, and that's because my slope is negative. Remember that if you're to graph a line x equals 3, that's a vertical line through 3 on the x-axis. And that slope is undefined. The slope of a vertical line is undefined. Because the x's are the same, and when you do your change in y over change in x, you get a 0 in the denominator, and that's undefined. If you were to graph the line y equals 2, which is a constant, it would be 2 through the y-axis, like this. And this slope is 0. And this slope is a D&E. Does not exist. So you need to remember that a vertical line, its slope is undefined, and a horizontal line, its slope is 0. Negative slopes fall from left to right, and positive slopes will rise from left to right. And I think that concludes all the information in section 1.3.